Good morning, everyone. My name is Jolly Vidongkoy, and for today's discussion, we were going to discuss my assigned topic, which is about spot welding and industrial cold working method. So, first, we will have our learning objectives. So, after the discussions, the students will be able to first know what is spot welding, second, explain the process in performing spot welding. And third, what are the applications of spot welding? And fourth, define cold working and its process in metal processing. And fifth, describe the specific process in different cold working method. And lastly, relate and purpose and importance of cold working in the industry or community. So first we will have our motivation. All you have to do is to answer the questions by choosing true or false. The first question is spot welding is also known as resistance spot welding. The answer is true. And the second question is spot welding process is used primarily for welding two or more metal sheets together by applying pressure and heat from an electric current to the weld area. The answer is true. Lastly, spot welding is typically used when welding particular types of sheets, metals, welded wire mesh, or wire mesh. And the answer is true. Alright, so as we go deeper in our main discussions, let's have first identify what is spot welding. Alright, so spot welding is also known as resistance spot welding. It is a resistance welding process. This is a welding process is used primarily for welding two or more metal sheets together by applying pressure and heat from an electric current to the weld area. And it is also works by contacting copper alloy electrodes to the sheet surfaces, whereby pressure and electric current are applied and heat is generated by the passage of current through resistive materials such as low carbon steels. So how does spot welding works? The process involves applying pressure and heat to the weld area using shaped alloy copper electrodes which convey an electrical current through the weld pieces, and the material melts, fusing the parts together, at which point and the current is turned off. The pressure from the electrodes is maintained and the molten nuggets solidifies to form the joints. And the welding heat is generated by the electric current, which is transferred to the workpiece through the copper alloy electrodes. Copper is used for the electrodes as it has a high thermal conductivity and low electrical resistance compared to most other metals, ensuring that the heat is generated preferentially in the workpieces rather than the electrodes. And the amount of heat depends on the thermal conductivity and electrical resistance of the metal as well as the amount of time the current is applied. The spot welding happens in three stages. First, electrodes seated in a weld head are brought to the surface of the parts to be joined and force or pressure is applied. Current is applied through the electrodes to the workpiece to melt the material. Lastly, current is removed but electrodes remain in place at first to allow the material to cool and solidify.
Resistance welding. Resistance is the property of the conductor by the virtue of which it resists the flow of electrons, that is, the flow of current through it. This resistance to the flow of electrons creates friction and heat. This heat generated is then used to join the two similar or dissimilar metals by melting and forming a bond between them. Types of resistance welding processes. 1. Spot welding. 2. Seam welding. Spot welding. Spot welding is also known as the resistance spot welding process. It is used to weld thin sheets of metal together by applying pressure. The heat required for welding is generated by resistance to the flow of current through the electrode. Working principle. The welding electrodes are made up of copper, which is a good conductor of electricity. The movable and fixed electrodes of the spot welding machine are held in pressure on either side of a pair of plates to be welded together. As the current passes, it experiences the resistance between the electrode and workpiece contact and generates heat. This heat causes the interface of the workpiece in contact with another workpiece to melt, and pressure fuses the two metals, thus forming a solid bond.
The weld electrodes are made of copper because copper has a low resistance to current flow, which allows it to conduct electricity with ease. Steel is a very poor conductor of electricity, and it will resist the weld current as it flows from the spot welder. The friction created by the current forcing its way through the metal heats the weld area to over 2,000 degrees Fahrenheit. The squeeze pressure from the weld electrodes now compresses the molten area and fuses the two metal surfaces into one solid nugget. By maintaining the squeeze pressure for a short time after the weld current is shut off, which is known as hold time, the molecules in the welded material remain compressed as the weld cools. This additional pressure results in a much stronger weld.
Because the metal is the electrode, and then you have a sandwich of metal, right? So this is good for welding lap joints where you have overlapping material, and then passes the electricity through there, through this other electrode, and back through this other arm, right? And so when you
Characteristic of spot welding. The spot weld quality characteristics are shear tensile strength and direct tensile strength has been considered. Signal to noise ratio was used to establish optimal process parameters to authenticate the contribution percentage of experimental results against specified confidence level, and ANOVA was used. Verification trials show that it is feasible to improve the quality characteristics considerably, and the investigational repercussions prove the effectiveness of the applied Taguchi method for improving spot weld quality. Spot welding is typically used when welding particular types of sheet metals, welded wire meshed or wire mesh. Thicker stock is more difficult to spot weld because the heat flows into the surrounding metals more easily, and spot welding can be easily identified on many sheets metal goods, such as metal buckets. And most common applications of spot welding is in the automobile manufacturing industry, where it is used almost universally to weld the sheet metals to form a car. And spot welders can also be completely automated, and many of the industrial robots found on assembly lines are spot welders or the other major use for robots painting. So the application of spot welding. Spot welding is also used in orthodontist clinic where small scale spot welding equipment is used when resizing metal for or molar bonds used in orthodontics. Another application is spot welding straps to nickel, nickel to cadmium, nickel to metal hydride or lithium ion, battery cells to make batteries. The cells are joined by spot welding thin nickel straps to the battery terminals, and spot welding can keep the battery from getting too hot, as might happen if conventional soldering were done. So, it also have a good design practice must always allow for adequate accessibility, and connecting surface should be free of contaminants such as scale, oil, and dirt to ensure quality welds, and metal thickness is generally not a factor in determining good welds. So we have personal protective equipment in spot welding. We should have safety glasses must be worn out at all times in our work areas, and long and loose hair must be contained. Sturdy footwear must be worn at all times in our workplace, and closed fitting protective clothing must be worn to ensure safety. We also have pre-operational safety check. Check workspaces and walkways to ensure no slip or trip hazards are present. Checks with gear and cables are in sound conditions. Check electrode points are in a good condition and meet exactly. And ensure electrodes are securely mounted and clean from the contaminants. And also seat pressure and clamps to hold work securely without damaging work. And preseat while time under your supervisor's direction if timer fitted, and also use gloves to position and hold work. For operational safety check, ensure the spot welder has cooled before making any adjustments, and avoid prolonged use as this can cause heat to build up in the electrodes and arms. And when holding work, be aware of the heat created during the welding process, and also ensure work return each cables make firm contact to provide a good electrical connection. And before um, ending operation and clean up, switch off the machine when work completed and leave the work area in a safe, clean, and tidy state. We also have potential hazards in a workplace. Electrodes become hot with continued use. We might be encountered burns, hot metals, spitting metals, or flying sparks, and also eye injuries. So do not use faulty equipments. Do not use the machine unless you have been instructed to ensure your safety in a workplace. So that is all for my discussion about spot welding. So let's now proceed to the next topic, which is our industrial cold working method. So industrial cold working method is a process done below the recrystallization temperature at a room temperature. Cold working is the plastic deformation of metals below the crystallization temperature, and due to high compression force, the grain structure of the metal changes and forms new shape. So what is recrystallization temperature? It is the minimum temperature at which plastically deformed metals form new grains or crystals within the specified time. Recrystallization temperature in most of the metals is found between one-third to one-half of its melting points. Cold working process. Cold working is a process done below the recrystallization or at room temperature, and due to high compression, force the grain structure or the metal changes and forms a new shape. This method is generally requires a high compression force as metal stack is passed at room temperature. Metals need to be at a room temperature or slightly above the room temperature, but below the recrystallization temperatures.
Hello friends, welcome to this lecture on the recrystallization of metals. So recrystallization basically means reformation or rearrangement of crystals in a metal. To understand this process, we have to first understand the basic structure of metals. So if we zoom a metal block, we can see that metals are made up of crystals. These are the crystals. And how are they formed? Well, grains are nothing but these are a group of atoms. That is, each grain is formed by a collection of atoms. So usually when metals solidify from their molten state, each atom tries to freeze down, and while doing so, the recrystallization is basically a process by which the old grain structure is changed and new grains are formed. Okay, so now let us try to understand this with the help of an example. Suppose we have this metal block. Okay, and these are the grains. Now, if we heat it at a temperature below its melting point, new grains will start to form from the grain boundaries. Okay, these new grains will grow in shape, and after some time, the old crystal structure will transform completely into new grain structure, and this process is called recrystallization. Okay, now why these grains are so important is because a number of mechanical properties depend on this.
We also have methods of gold working process. First, we have forging. It is the mechanical reshaping of metal by hammering or pressing. We also have gold ruling. This process is done by passing the metal stack through the pair of one or more rollers to achieve uniform thickness or decrease in thickness with the increase in length. We also have gold extrusion. It is done by passing the metal stack or piece through the dies by applying a compressive force to change the shape of the metal piece. And gold bending. The metal can be deformed by applying the stress beyond the yield strength, but without the ultimate tensile strength, there is no effect on the surface area of the metal. So we will have the advantages and the disadvantages of gold working. First, we will discuss about gold working advantages. We have the cold working procedure produce a smooth surface finished. This produces an accurate dimensions of the parts. It increases the strength and hardness of the metal but reduces the ductility. At this procedure, it is performed without heat so no oxide is formed on the surface resulting in a smooth surface. And also this process is mostly used for bulk production and the defect in this process can be easily detected and can be removed. Heating of metal is not required as it does not require heating, it results saving cost and strain hardening occurs. We will also have the cold working disadvantages. Cold working requires a clean and smooth surfaces. Brittle metals cannot be cold worked properly, and it requires a higher amount of force to begin and end the work. And it also requires more powerful equipment, and due to higher yield strength and low ductility, the maximum amount of deformation that can be given is limited by the capability of the press and hammer. So the application of cold working process. The cold working process used to manufacture different products in industries like large flat sheets, metal tubes, screw heads, and riveted joints, and much more. Cold working is used by different industries like aviations, iron, and steel automobiles, and many more. As this process gives smooth finishing and strength, it also used after the hot working of metals by the application of different methods of cold working like shearing, cold rolling, cold extrusion, and multiple products are produced. And that is all about my discussion. I hope you learned something. Thank you and God bless.